Hello everyone, welcome. I hope you can hear me okay, and I hope you had a good break as well. I know it's just been half term, even though things aren't sort of as normal. It's nice to see some of you already in the chat, and I hope you're all keeping well. As I'm sure you can hear from my voice, the pollen count's high where I am, but we're going to be looking at some of the statistics content of the A-level today. We're going to look at frequency polygons. Welcome if you're just joining as well. We're only just starting. And if you look in the chat, you can see the slides have been attached for today's PowerPoint. Hi, welcome. Good to see you all in the chat. Hopefully this is all coming through clearly. And I'll just give it a minute for people to join. How are we all? Excellent. Okay. So this content that we prepared, I've prepared is kind of on year 12, and some of the stuff will help for year 13 as well, but it's very much pitched at year 12 students, AS, A-level maths. A lot of the content sort of rolls forward. So now and then it will be a bit of a recap of GCSE stuff, but in a very much A-level setting. So that sounds kind of ideal. I think the idea of cumulative frequency is something we might have seen before, but it is covered at A-level as well. So year 12, typically statistics part of the course. Excellent. How are we all? How are we feeling? Have we had much through from schools or colleges, information about what's going on for the next half term? It's a little bit vague still, I think, but hopefully we're kind of all still able to get on and work okay. How are we? Let me know in the chat, and I will shortly be sharing the screen so you guys can follow along. Oh, wow. Yeah, it's tricky. I think, I mean, it's great to see so many students being productive with their time and, you know, doing their own work and just kind of taking hold of it and being independent with the learning, because it's really hard to sort of facilitate that learning for a lot of schools. So hopefully anyway, what we're doing here is helping a bit. But as I said, I'm going to share my slides with you now. So please look in the chat if you haven't already for the slides. There's a copy of it that one of my colleagues has dropped in there. So feel free to open that up and let's get started, I suppose. Oh, cool. Oh, okay. Excellent. Well, that's good to know. So yeah, that's great. I mean, you can kind of crack on with that stuff already. Brilliant. Right, here we go. So let me just share the correct thing. Here we go. Right, let me know that you can see this. Hopefully that's nice and clear on your screens now. And I'll just go back a second. Whoops. Oh, no, I'm flying through the presentation. Right, good. I'm just getting myself set up so I can write on this screen, but I think I'm good. Right, so yeah, so different sort of timings with the schools, as I can see from the chat, but I think that's kind of to be expected. Excellent. Right, is this all clear? Is this taken over your screen? It looks like it has. Super. Right, here we go. So what we're going to do today, we'll look at cumulative frequency. Towards the end, as I'm sure a lot of you are aware, there'll be a coupon code for Snap Revise, just to kind of remind people that obviously there's a lot more on the platform in terms of A-level specific content targeted at all the different areas of the A-level syllabus for the different boards. So there's a lot of resources on there, and I'll talk a little bit more about Snap Revise towards the end. So hopefully you've accessed the slides, PowerPoint slides. Here's the first question. I'll read it out and then we'll talk it through. But feel free, as always, to submit your answers in the chat where possible. If the question is like draw a graph, obviously that would be quite difficult, but I'll run through them all anyway. So here we go. We've got the diameters of 100 pebbles were measured. The measurements rounded to the nearest millimeter, X, they've called that variable, are summarized in the table. And then you're given the table there with the numbers, and we've got kind of grouped data going on. And we've got to be very careful with this, because although cumulative frequency is something you cover at GCSE, there's a kind of little subtlety here that we need to be careful with. So for a cumulative frequency graph, it says state the coordinates of the first 2 points that should be plotted. So hopefully we remember from GCSE, a cumulative frequency graph is like a running total of the frequencies of all the groups. And so it's kind of this S shape type thing. It's a little bit of a kind of skewed S shape, almost like an integral sign a little bit. They typically go upwards to the total frequency by the end. And it's like a running total, and that is what cumulative means. Any ideas what we would plot as our first couple of coordinates to start this graph off? I'll give you a minute to have a little think. So look at the table, think about what's going on. And this is a weird one because it's not starting from 0. It's kind of starting where X has a diameter and there's a sort of first value there. But be very careful with how these classes and intervals overlap. Does anyone have any suggestions? Feel free to put those in the chat. And I will give you a minute, but apologies, sometimes the chat is a bit slow loading for me. So I want to give everyone the chance to type it in. Okay, right, we've got some suggestions, and I think some sort of sensible suggestions there. Yeah, we do need to be very careful here because absolutely it looks like we're looking in the right place. 25 is certainly going to be the frequency or the cumulative frequency of the first one. However, what we need to kind of be really careful with is that the boundaries don't overlap. So this is a little bit weird. It's a bit like those questions in statistics where they go 10 to 19, 20 to 24, 25. Now, the problem with this is we've said it before, these are continuous variables. So in order to properly make it continuous, where does the boundary of these classes really need to be? Because you can't have gaps. So if it's sort of 10 to 19 inclusive, where is right? Absolutely. So this boundary is actually 19.5. Okay, and we actually also need to consider the boundary here as 9.5. So excellent. So it's a little bit tricky, that one. So just to double check, your first two coordinates are actually going to be at 9.50. And the next one is going to be up at, has anyone suggested it? So this will be 19.525. So basically, rather than starting excellent at 0, 0, it's not starting at the origin, it's starting at the lowest value, and we're taking that boundary as 9.5. So this is an easy one to mess up. And then the next value is going to be the end of the interval, 10 to 19. But we're really being careful because we know that means 9.5 to 19.5. With a cumulative frequency or running total frequency of 25. So that would be the Y ordinate part. Is that kind of clear? Does that make sense? Because I think this is a really important thing to bring to light. And it sort of shows us that although it's an extension of GCSE, there's nothing particularly mind-blowing going on here. It's one of those subtleties that they will pick up on at A-level and they will actually specifically test. So hopefully that's nice and clear. Cool. So following that, it says, why is it not possible to draw an exact box and whisker plot to illustrate the data? So box plots or box and whisker diagrams, box and whisker plots, hopefully you remember what they are from GCSE as well. But for something like this, why is it not possible to do that exactly? Any suggestions? So think about the kind of data we've got, how we would present this on a cumulative frequency diagram, and why then it wouldn't be possible to do it exactly. Lovely. Okay, yeah, we're all kind of getting the correct ideas there. Super. So I'll write this in as well. Absolutely. Good. Lots of good points being made. So we don't know exact values. We're given group data. We know that the data falls within 10 to 19. There's 25 things, but we haven't got the raw data as a list. Absolutely. So because essentially, as we've said there, we don't know exact or specific values. Brilliant. Super. Yeah. So this is lending itself to a cumulative frequency diagram or cumulative frequency graph, not at all really lending itself to a box plot. And we don't even know exact. So we don't, if you specified, don't know the maximum or minimum values. And we don't even exactly know the quartiles. So we could do this sort of interpolation approach and get an estimate for them, or quartiles. I'll put that in as well. So it's very tricky, but excellent, brilliant suggestions there. Cool. So let's keep going. And hopefully, as I said before, you can have access to the slides. If you go back in the chat, they have been pasted into there. So you can open those and follow along. You might work ahead, that's fine. Right, let's look at this one. So the number of births in thousands to mothers of different ages in England and Wales in 1991 and 2001 are illustrated by cumulative frequency curves. I don't know if this is where this is taken from, because the results might actually be quite surprising here. But let's look at this and don't overcomplicate it. So for part one, question one, and some people have shared answers as well, excellent. It says, in which of these 2 years were there more births? And how many more births, I think I might be blocking that bit of the question, were there in this year? Oh, okay, cool, now you can see that. So, absolutely, I totally agree with you all. It's 1991. We can kind of see that for 1991, the total births reaches a higher value, okay? And then it says, how many more births were there in this year? Excellent, right. I think there will be an interval of tolerance for this, because it's a very small scale to be reading off hundreds of thousands, but you would basically be given any value in the interval 100,000 to 110,000 would get you the marks. So 100,000. Now you'd only need to write one of these, but I'm just sort of pointing out what the mark scheme would allow for. And this is 2 marks, because although that was hopefully an easy mark, it did ask you 2 things, so make sure you answer it properly. Absolutely, and that's a really important point. We're basically at 700,000, we're basically at 600,000. The difference is approximately 100,000, maybe slightly more, because the gap is a bit more from here to here. So the other thing, obviously this might be very obvious to you, but watch out for not saying 100, because if you just quickly look at that scale and you go, well, 700, 600, remember this is in thousands, and it does say it clearly, so you would lose marks for that. And obviously sense checking it, it's not going to just be 100 births, it's not just going to be nationally 700 births. So be really careful with that, but hopefully that's nice and clear. Well done. Okay, so good question there. How do we know if it's an approximation? I'm going to talk about that a bit more specifically later on, because there will be questions that say estimate, and we need to understand what it means. But anything where you're reading off of a graph, you try and read it as accurately as you can. But obviously something like this, you're not going to know it to the single unit value. It will be to the nearest 100,000, 10,000, however the scale is. They'll be tolerant on the scale, but within reason, okay? That needs to be between 100 and 110. And that would be fine. So for a graph question like this, you read it as accurately as you sort of physically can, and that would get you the marks, okay? But there will still be some tolerance for it. And it won't say estimate, it will just ask you. However, we will look at questions that ask for us to approximate or estimate with cumulative frequency, and we do need to be careful there, because I think sometimes with a maybe GCSE mindset, or with the kind of thought that the exam board will be lenient or whatever, we have got to be careful, because even when it says estimate, we need to still do some things very exactly, and we'll talk about why certain questions refer to it as an estimate. But very good, a good point there, and hopefully that's clarified for this one. You read it off as best you can. Excellent. Right, let's keep going. So this one here, it says the following quantities were estimated from the diagram, and then it said find the missing values. So they've started it for you. They've done it for 1991. Excellent. So we've got to do the same for 2001. Now the median, how are we going to find the median for 2001? So how do we do that? So, and a lot of people look at the kind of end age and half it, but you've actually got to half the total frequency. So if we assume this is about 600,000 or slightly less, then it's going to be just under 300,000. Brilliant. So you go along, and we've got to carefully pay attention to 2001, that we're not halving the age, we're halving the total frequency. So you'd go along to 300 and read down. Okay. And what we'd get, you'd go down to the value there of the age. And the mark scheme for this question would actually any age between 29 and 30, but just below 30. Okay, so 29 to 29.9 type thing. So what we're going to have for that one, let's say 29 as the median age, because it's below, it's not quite 600,000, but we're going to take it as that because we can't do it much more accurately. So about half of 600,000 is 300,000. But the point I'm stressing at is this is the bit we halve. It's out of this many mothers. So if I want the median, I go to the middle number. Had it been the 700,000 one, I'd look to the 350,000th person. Okay, so hopefully that's clear again from reading off cumulative frequencies from GCSE, but definitely worth a recap. So yeah, any of those values, 29.5, 29, that would be good. Absolutely, and a brilliant suggestion for quartile 3. So remember the IQR, the interquartile range, just as a little reminder of what that is. The interquartile range is the upper quartile minus the lower quartile. So basically 75% of the way through the data minus 25% of the way through the data to essentially give you how spread out the middle 50% is. So you know that the range is the biggest, take away the smallest. The interquartile range is the biggest quartile, take away the lowest quartile, to look at the spread of the middle 50%, the middle 2 quartiles, which is essentially the middle half. Excellent. So if you go up to sort of 450,000 or thereabouts, as best you can, and remember we're using the 2001 line, read that down for your upper quartile and do the same at 150,000. Read that along. And I think some of you have suggested this in the chat. Sorry about my wobbly lines here. And I think I totally agree with you there. We're looking at a value between 33 and 34, they'll accept, and a value between sort of 24.5 to 26. So let's say 25 and 34. And then your answer for that interquartile range bit is going to be anywhere between 7.5 up to 9. Okay, you'll get a mark for. So let's say 8. Yeah, 8 or 9. We would have got 9 using that calculation there, wouldn't we? 25 up to 34. Okay. Brilliant. Yeah, 8 or 9. 8's maybe more sensible if you went a little bit less for each of them because it wasn't exactly 600,000. But as I said, there'll be an interval of answers that are okay there. Then it says proportion of mothers giving birth aged below 25. So how do we do that? So aged below 25, well, that's going the other way. So the way I've done it, it looks like it's bang on our quartile. So yeah, that's about 25%. Good. So you're reading it from the ages and then looking at what percentage of the data that accounts for. Super. So then what it says, so that's spot on. So I'm going to just quickly copy that now onto my next slide. So hold that for, it was 29, we'll say 9, 25%. Lovely, excellent, and thanks. That's kind of a nice calculation had it not been a nice quartile. Super. So about 25%, spot on. Now it says, did women who gave birth in 2001 tend to be younger or older than or about the same age as the women who gave birth in 1991? Using the table and your values from part A, give 2 reasons for your answer. Now, it's a bit weird because it's kind of 3 marks, but we've got to be very careful with these comment type questions because they're often 2 or 3 marks, but they need you to contextualize it. You have to refer to the scenario. You can't give a real pure mathematician answer where you ignore all the context and just talk about the numbers. You have to put this into the perspective of whatever the context is. So we need to be careful here, because you might remember that at GCSE, a lot of these comment questions wanted you to not only talk about a measure of location, but also a measure of spread. So sort of how they're sort of spread out, but also how they, whether they're like bigger or smaller in terms of the range and the interquartile range. So let's have a little look at suggestions we have here. Good, so a lot of good justifications coming in. Good. So in 2001, let's have a little look if we compare specific. Yeah, so basically something along the lines of the median is greater. And we can be sort of specific, but basically the percentage of older mothers is greater. Or on the flip side, you could say the percentage of the other one's younger mothers is less. Okay, good, but that's kind of key. We don't know the populations, but I think because this is a direct comparison of births, we're not accounting for that. That's a really nice point though, because in some contexts that would obviously actually be really important, but we're doing a direct comparison. So all the other variables like the actual population and stuff, we're not including, we're not interested in, which is weird because we probably would be if we were to do this without just doing a straight comparison of births. So a really good point there. Is that all kind of clear? I think you've made some really good comments in those answers, guys. That was really good to see. But I think pick specific values, actually, as some of you have done, referring to your table, referring to the quartiles or the median, and then make your conclusion from that. And if you make a sensible conclusion based on evidence that's quite clear, you'll get the marks. Okay. But that is a really interesting point about the actual populations, which is very likely to have varied in that time. Good. How are we feeling with that? Little sort of comments in the chat would be great to know how we're feeling, but certainly looking at your answers, that looks great. Well done. Good. I think we'll keep going. So excellent. So this one here, let's look at this one together. The marks of some students in a French examination were summarized in a grouped frequency distribution and cumulative frequency diagram was drawn, and that's what's shown here. So have a little look at this for a minute. So students doing a French exam. Right, good. It says estimate how many students took the examination, and we know it doesn't reach 600, so we've got to be very careful with the scale. It's going up in 20, isn't it? 20, 40, 60, 80. It looks bang in the middle. So I would totally agree there. That looks like 590 students, 595 you probably get away with as well. But let's be careful. It's halfway between the 580 and the 600 box. So we're probably safer going with 590, but that's good. Yeah, excellent. So that's all they're testing. Can you read where it stops? Which we've got to obviously be careful with. It's only a 1 marker. Lovely. Right, let's keep going then. Here we go. And then it says, how can you tell that no student scored more than 55 marks? So what answer would you give? I mean, these aren't particularly long answers, but how would you write your answer to get you that 1 mark? How can you tell that no student scored more than 55 marks? And say it very simply, state it very plainly. Why do we know that? Yeah, exactly. Yeah. Yeah, all really nice ways of saying it. Basically, yeah, the graph just becomes horizontal from then. It's flat, it's horizontal, it stops. Absolutely. So graph becomes horizontal for marks greater than 55. Absolutely. So it's suggesting you've reached your total frequency, your total cumulative frequency, which is everyone. and no one's getting any more than 55 marks because the frequency isn't increasing anymore, suggesting we've accounted for everyone. Brilliant. Right, let's keep going then. So the same setting again, same question, another 1 mark here. Find the greatest possible range of the marks. So let's think about how we'd do that. How are we going to work this out? What do we reckon? Okay, so what do we get? So we're looking at our highest mark being 15. That certainly looks sensible. Good. And what's our lowest mark? Let's be careful. It might be sort of somewhere between 14 and 15. Yeah, so excellent. Your answer that would get you get your marks here for any answer between 39 and 41. I think 41, if we're using 55 sort of as the cutoff value there, and 15 as the value there. And remember, if this is an interval, it could be that it goes down to sort of 14. Because remember, these are grouped frequency intervals. So that 15 is actually plotted at the end of an interval, which starts somewhere. So it perhaps starts at 14 or below. But yeah, let's be very careful with that. But 41 would be, yeah. I would probably say, look at the context as well, because it's probably going to be whole marks. But if you actually have an answer that's between 39 and 41 and it is even decimals, you would get, it would be in the correct interval. So yeah, they'd probably allow for that in this question. Good question there in the chat. Lovely. So they're not particularly difficult scenarios. They're just very specific things that we're looking for. 1 markers. And that's pretty much how stats is a lot of the time. It's, can you contextualize it? Can you explain it in a proper, well-worded answer that's succinct, clear, and obviously accurate, and using the correct terminology as well. Right, here we go. Let's look at this one. So this says the minimum mark for a grade C was 27. The number of students who gained exactly grade C was the same as the number of students who gained a grade lower than C. Estimate the maximum mark for grade C. So we've been told where 27 is, so we can kind of put that on there. 27 is there. So what can I do here? And I can obviously trace this along to see the cumulative frequency of students who got worse. It kind of is, yeah. It's sort of using your graph and trial and error, yeah, absolutely. But also we have got some specific values that we can look at here. And again, they'll accept an answer, give or take a small margin. But what do I know? So 27, up to and including a score of 27, was how many students? How many students got up to and including? So up to and including, we've got about 180 students there. And excellent for submitting answers to this, guys, for where the next boundary is going to be. 180, yeah. So if I want to, let's reread the question here. If it says the minimum was a 27, so below 27, there's 180 people got less than that minimum mark. And because it says the number of students who got a grade C was the same as the number who got less than a C, that means there must also be 180 students that were in the grade C sort of band of marks. So what we need to do is think, right, I need to add another 180 on to that cumulative total to see what mark would bring me up to another 180. Okay, so if I look up to 320, 40, 60, go along to here, sort of read that down, it is going to be very close to 31. So actually any answer, it's actually allowing in the interval between 29 to 31.5. But basically, yeah, I think 31 certainly looks sensible for reading it off, maybe slightly more. I'll write that in, 31. Can everyone see what I did in terms of looking up another 180 in order to sort of band the C grade marks are sort of for values within here. So if you got between 27 and 31 marks, you're in the category of students that got the C grade. Anything less than that, you got less than a C. We've not been given further sort of clarification on how the grades would work within that, but we know it's less than a C. And likewise, we don't know the other side of the scale. Yeah, absolutely. So the first part of the question said the minimum mark was 27. So the first thing I'm going to do is go to 27 marks, trace it up to the line for cumulative frequency, and move that back across to see the cumulative frequency of students who got lower than a grade C. And there was 180 of them. And in the question, it said the number of students who gained a grade C was the same as the number of students who gained less than a grade C. So that means the people that got a grade C must also be 180 people. But remember, this is a running total. So all the people who've got worse than a C and a C will actually take you up to 360 people because you add another 180 on. And we know that this next lot of people get the grade C. So now we're going back the other way. You go across to your cumulative frequency diagram, go down to the marks, and we see it's around 31. And they'll be tolerant with how you've used the line, but 31 I think is a sensible one to read off. And then that will bound the upper boundary of the grade C so that we know, okay, then between here and here, it's risen by 180 students, was the same amount as those that scored lower than a grade C. So I found the upper boundary by adding on the same frequency to the cumulative amount in order to move on from the lower bound of the grade C. Excellent. But thanks for kind of ensuring I clarify that, because there was a lot going on there. And although in hindsight, it probably seems okay, the wording of this, we could reinterpret in so many different ways. And also even it's very easy to just do it slightly wrong. So thanks for that. Hopefully that's clear for everyone. Now we're going to move on again. I think it might be the same scenario that we're looking at. Let me just check. Yeah, so here we go. So it says, in a German examination, the marks of the same students had an interquartile range of 16 marks. What does this result indicate about the performance of the students in the German examination as compared with the French examination? So think about when we're contextualizing it, what the interquartile range is actually a measure of, and then what it's indicative of in this context. So the students have done a French exam and a German exam, and we know their interquartile range for German exams because they've told us. So what might I need to calculate first here from my graph? Because remember, this graph was for French students. What would I need to do for this one? And apologies if you're writing answers in. Sometimes the chat takes a bit of time to load for me. So yeah, excellent. So we want to look for the interquartile range for the French students. So let's use our graph to do that. Now, remember, this was about 590. So half of that is 295. So we do as best we can to read off where the median is. But remember, we want the lower and upper quartiles. So we want to work out the interquartile range for French students. Do let me know if you found it. That would be brilliant. And I'm sure some of you have probably gone on and done that already. So for French students, I think the upper boundary so the lower boundary is going to be about 147.5. So it's sort of halfway through there. It's this terrible little line I'm drawing. Okay. Get down to maybe about 26. I think the upper boundary. About 34 or 34.5. So making the interquartile range basically depend on how accurately you did it. Anywhere between 8 to 10 would get you the marks. So if you got 8 or 9, that's absolutely fine. Well done, yes. So the upper quartile, let's say, upper quartile, I'm going to go with 34. Lower quartile, I'm going to go with 26. And so there we're going to get an IQR of 8. Okay, and they will allow between 8 and 10 as your, depending if you've done it slightly different. So what does that tell us? What does it actually tell us in the context of the question? Okay, I found the interquartile range of the French students, and I found the interquartile range, well, I'm given the interquartile range for the German students. So how do I make the comparison? Any comments or suggestions on what this actually tells us in the context of these language exams? Because I think we're all pretty much in agreement, hopefully, of the interquartile range value. But what does it actually tell us if we were to comment on what we can see? Okay, so we've got to be careful with some of the wording here, because a lot of the time when we say one's better than the other, we're talking about a measure of location, or the median was better, so on average they performed higher, or and so on. So you'd probably use median or a highest value or a quartile value to do a direct comparison of which was the better subject for them. However, this is a measure of spread, absolutely. So it may well be that they actually did better, but it's more about their consistency and how spread out the marks were. So I would probably state then that the marks for German were more spread out, because that's actually a very different point to whether they were better at it or worse. There was just a broader spread of marks. So the best person might have been way better, but the worst person might have been a lot worse. So marks for German were more spread. So something referring to the spread shows that you've interpreted the interquartile range sort of in the correct context. But other things like that, when we're asked to do a comparison, you would use a measure of location for commenting on if they've done better or worse by using a location measure. Excellent. Right. So there were some really good questions there to look at. What I'll do now, because obviously this was part of the statistics, is I think I'll show you some bits on the site, and I'll look specifically at some of the statistics stuff. So let me just share my screen with the correct screen, hopefully. So hopefully you can all see the Snap Revise website. Is that something we can see? Hopefully that's nice and clear. Okay, so just to talk you through quickly, what we've got on here is we've got loads of stuff in terms of web classes and drop-ins. Sessions a bit like this, where we've kind of gone through all of the content with a whole backlog of topics for the whole A-level course, mechanics, pure and statistics. And there's web classes happening all the time and drop-ins. And we do a bit of pure, bit of stats and bit of mechanics. We tend to do more pure because there's more pure content, but it's all completely in line with the kind of proportions of what you'd be doing in school. And so really nice, clear web classes and a backlog, as I said, and you can kind of look through and see which classes that we've done before were on probability. So here we go. Here's an old mechanics one, pure, and so on. And you can engage with them live, just like you've been doing today. And also the course is really tailored to help you with diagnostic quizzes on all the different topics, as well as really nice, clear notes. So there's a lot of stuff at A-level that's really brand new. And what you can do is do a quiz that will pick up on where you're strong and where your kind of weak points are. And then it will kind of tailor the revision to help you. So I'm going to quit that for a second. But then what you do is you can follow it up with videos that jump to the points that you need help with really nice, clear, really well thought out notes, as well as, you know, revision guides that are just really simple and straightforward that you can print off and stuff and download. So excellent to have all these extra resources, and it is certainly something you might want to check out. So I'll just stop sharing that for a second and return to, hopefully you can see me again. I'll just reshare the slideshow. Right, so can we all see that? Let me just get your comments back up. Lovely. Thanks, guys, for engaging really well with that today. As I said, this is the statistics stuff. So there's a real breadth of topics at A-level. And that's, for a lot of people, a big challenge, particularly the applied. A lot of people tend to have a preference over statistics or mechanics. And unfortunately, it's all examined together now. So because the course is linear and you have to do pure stats and mechanics, you have to have a real broad understanding of everything. And as we've seen today, the stats is very specific. So the way that the marks will be structured are for you to hit very specific points. And that's what we've looked at. So it's been excellent that you've engaged so well with that and been able to ask the questions as we go. I'm just checking through the chat because I couldn't see it for a minute there. In terms of the schedule on the website, I'm not sure if the individual schedule, so the schedule for YouTube is obviously up and you can set reminders and stuff on YouTube. So all our YouTube classes will be there. In terms of the schedule for Snap Revise, if you do sign up with a login and an account, and here's a code if you're interested for a discount today, then you can get access to all of the videos we've done throughout the year and in the past. And there've been individual, like personalized kind of web classes to specific topics where we've answered questions students have had live, sort of real time. And also it will have the schedule of all the up and coming web classes that are happening every day. So I hope that answers your question. If you want the schedule of what we offer on the platform, I think, but I maybe need to be corrected here, I think you need to have a login to see that, and certainly to be able to access any of our previous stuff, you would. But there's lots of different courses, obviously, for all the different A levels. So if you are interested, feel free to kind of inquire, use the discount code, check out the website anyway, because there's kind of a lot of information there as to what we've got going on. Oh, okay. So when you go on the course, if you have got a login and you go on your course and then you click web classes, so there should be an option for web classes and drop-ins, and then you scroll down to all the ones that are coming up, and then after that there's a kind of backlog. But you need to go on the specific course that you're looking at and navigate your way through there. So hopefully that's something that you can play around with, but feel free to email in or message us if you need further help with that. But that should all be accessible there. And then, as I said, all the YouTube ones are nice and clear because they're on the YouTube page and they'll be coming up as normal. So now it's obviously not half term anymore. We're still running them as normal, and obviously bring your questions along as well if there's any specific things. So yeah, if you want to email in, I think the email address has been added there. So thank you to one of my colleagues who's just dropped that in. Brilliant, excellent. And then, as I said, you've got a whole backlog of resources plus loads of new bits going on every day. So thanks very much again, guys. Remember, this is your code if you're interested by the end of today. And we've got loads more sessions coming up for all the subjects on there. So check them out, set reminders, and it'd be great to see you all at some point soon on here again. Big thanks again to everyone for working so kind of proactively alongside that and asking questions. Keep well, take care, and hopefully speak to you at some point very soon. Excellent. Thanks, guys.